Hi everybody, and welcome to our next video in Excel for statistics. In this video, I want to talk to you about the binomial distribution. So we can find probabilities for binomial experiments in a few different ways. So one is using the formula by hand, which works in all scenarios, but can be a bit tedious to use. Second is with tables, and tables are very fast to use, but they don't work in all cases since the numbers only go so far. So our third option is to use technology, and I'm going to show you how to do this in Excel. And this can be really helpful, particularly if you have to do lots of calculations. We don't really want to use the formulas over and over and over again. It would take us a really long time. So we can do that here in Excel. And I'm going to show you two different formulas that you can use. So the first one is more standard. It's just binom.dist for distribution. And you do need to plug in a few different things here, though. So the first thing you have to plug in for the binomial distribution would be the number of successes. Um, so let's see. We'll write it like this. So number of successes, or this is also your X value. The next thing you need to type in would be the number of trials, and that would be your N. Then you need your probability of a success. And then finally, you're going to actually write the word false. And the reason why we use the false is this makes it not cumulative. So cumulative means it adds up all the values below it as well, which can be helpful sometimes, but in most cases we want to find individual values. So another way to write this is, again, binomial distribution. And to clean this up a little bit, the first thing you're typing in would be your X value, how many successes. The next thing you're typing in would be your N value, the number of trials, then your P, and then finally that word false. And again, using the word false gives you just the individual values. Cumulative adds up everything below it as well. So for instance, if I was doing 5 successes and I did not put false, if I put true instead, it would actually give me the probability of having 5 or fewer. So it would count everything below it as well, which is not what we always want to do. So most times you're going to be using that false piece. So for instance, let's do our example here. So binomial dist, I'm going to just double click that. And again, it reminds you what you have to plug in. So number S would be the number of successes. So let's do 5 successes. So I'm going to do 5. Then I need the number of trials. That is going to be 10 in this case. So we'll do 10 trials. My probability for success is going to be 0.3. And then I'm going to go ahead and just either click or type in false and then hit enter, and there's your answer. So again, it's really, really quick. So here, N is 10. In this case, our X is 5, and our P value is 0.3. Now, in this last example, I typed the numbers in directly, so you could do that too. Or if you prefer, you could click them. So number of successes would be 5. Number of trials is 10. Probability of success is 0.3. And then again, we're typing in that word false or clicking it, and we can get the same answer. Now, why do I like using cells sometimes? Well, if I have to do this more than once, so maybe I'm doing a question that wants me to use the same setup. So 10 trials, probability is 0.3, but it wants me to find a bunch of different X values. Well, I could just change it here. So maybe I need to find what happens for 0 successes, right? If I change it there, my whole formula updates. Or 1 success, updates. 2 successes, etc. So by using the cells, it does help to save some time. If you're going to be doing similar questions over and over again, then you can just tweak your values here and make that update. Now, another really helpful version is this. So it's binom dot dist dot range. And what this does is it calculates the binomial distribution for a range of values. So let's say you want to figure out what's happening between, I know, X is 1 and X is 5. So you want from 1 to 5 successes. Well, normally we'd have to do this individually. We'd have to find 1, 2, 3, 4, 5, and do them all one at a time, which is not too bad using this formula here. But if you know that you need a range, we actually can use this formula instead. And what you end up typing in here is you actually type in the number of trials first, the probability of success second, and then you basically do your first X value, comma, your second X value. So for instance, let's say I wanted to do from 1 success to 5 successes. I could hit equal sign, type in binomial distribution range. My number of trials in this case is going to be 10. My probability is 0.3. And then I would like to know the probability if I have anywhere between 1 and 5 successes. So I do 1 comma 5, hit enter, and it calculates that whole range for me. And again, if you prefer, you could do your cells here as well instead. So let me just show you one quick example. So let's do something smaller. Let's do, all right, so let's say we have only 3 trials. Actually, make it easier. Let's do 2 trials. 0.4 for my probability of success. And then we'll do all the X's. So for instance, X could be 0, 1, or 2, right? 0 successes, 1 success, or 2 successes. So if I want to do these individually, I could do that. Binomial distribution. All right, so my first number of successes would be 0. My number of trials is going to be 2. My probability of success is going to be 0.4. And then I'm going to use false. So this is what happens when X is equal to 0. That's the probability there. Actually, let's write it like this, P of 0. So now let's find P of 1. So I'm going to do the same thing, binomial distribution. I want 1 success this time, 2 trials. My probability is 0.4, and again, I'm going to type in false. And then finally, I could go ahead and calculate the chance of having 2 successes. So I do the formula one more time. All right, my number of successes here is going to be 2. I have 2 trials. My probability is 0.4, and then I get false. And there is my value for that last one. And we can always check these by adding them up. So I can use the sum function here. And if I add them up, I do get that value of 1, which I should have if I have a full probability distribution. So if I have the probabilities for every single possible X value. So we did that pretty quickly still, right? Maybe it took us a minute or so, but we did that pretty quickly, much faster than the formula. But again, let's say we wanted to actually find the probability for 0 or 1, right? So I want to do both of these together. Well, now I have both answers, so I could just add them up, right? So that's one way to do it. I could just take the answer from here, and I could add it with the answer from here and figure that out. But I could also use that binomial distribution range. So if I use that, I have 2 trials overall. The probability of success we said was 0.4. And then for my X values, I'm going to go from 0 to 1, right? I want to include both of these. And if I hit enter, there's that answer as well. So it's just a nice tool, particularly if you have to find a range, but you don't necessarily have to find all the individual values. You can kind of jump right to that solution there using binomial distribution range here. So again, that's really helpful. The other way that you could do it, not to get too involved here with this, is that if we put true here, it does give us a cumulative. So for instance, the probability of 1 or less, if we use that original binomial distribution formula. So let's see, how many successes? I have 1 success as the highest, 2 trials, 0.4. And then if I use true here, then what happens is you get 1 or fewer. So in this case, it's 1 or 0. So it'll count down to 0 for you. So some different ways to save you some time with ranges here. But if you don't want to go that detailed, as long as you can do the regular binomial distribution function here, you can at least get the individual values, and then you could add them if you needed to, if you wanted to group data or look at more than one success category at a time. So I hope that was helpful. And if you have questions, just let me know.